Hello everyone, I am Professor Niro Betta, and in our session of IC engine component design, today we are going to determine design of cylinder block assembly. In that cylinder block assembly, previously we have learned about determine thickness of our cylinder wall. Today we are going to determine length and bore of our cylinder. How we are going to determine this length and bore? Because this is the major aspect of our cylinder. Because it will also consider or it will also decide our power which is generated in our cylinder piston assembly. So this is the one of the most vital design when it comes to cylinder block design. So by designing this determination of this bore and length, we should know about what kind of power requirement. So basically this concept of designing bore and designing this length is more of about our requirement. So we are going to adapt the requirement as our input criteria and length and bore is output criteria. What is our input criteria? Our input criteria is power of our IC engine. So what is our requirement? If some company or if some engine or if some automobile company wants to design some IC engine with the power of 2 bhp or something, so that is indicated power, or you can say that is input of our power. What is this indicated power? Indicated power is power required by any engineering firm without designing or without practical experience of that engine, which is also called input or required power. By designing this, by replicating this power into something, by geometrical consideration or any other arrangement, we are trying to find real power, or you can say brake power, which is also we can determine at our flywheel. So indicated power is basically nothing but a predicted power, or you can say indicated power or input power, and brake power is nothing but one of kind of output power which we can find at a flywheel. So ultimately, indicated power and brake power, the difference between both of them is that indicated power is geometry, or you can say that kind of power is predictive power. If some engineer is saying that this much of power my engine develops, it's depending on, if it is depending on geometry, that is called indicated power, and if it is after that practical work or after that finding that power at our flywheel, that is called brake power. So this is the basic difference between indicated power and brake power. So our bore and length of our engine, or you can say cylinder, it is determined with the help of this indicated power. For that, we should know about what is our requirement of power, or you can say power generated inside our cylinder. So bore and the length depends on the power generated inside cylinder. So you should know about what kind of power is generated inside our cylinder. This is mean effective pressure which is going to develop in our engine. D is the cylinder bore inside in mm. In previous case we have taken as a DIU. In here we can also take it as a D. Simply D. You can take it as a simply D. Here, so that is different. There is no difference between DI and D. It is the same. The cross section area of this component. So here in this case, this power will act vertically upward. So ultimately we are going to take, and we have to determine bore of our cylinder. So that's why we are going to take this cross section, circular cross section area of our cylinder. After that, the length of stroke. What is length of stroke, which we have to determine depending on this indicated power. Speed of our engine. What is speed of our engine? And this is number of working stroke in our engine. In case of 2-stroke engine, we are going to take N as a number, which is that, and in case of 4-stroke engine, N is proportional to capital N by 2. So in case of 2-stroke engine, you have to take N, small n is equal to capital N. In case of 4-stroke engine, you have to take it as N by 2. So here in this case, power produced inside cylinder, this is just predictive power. This is not actual power. Actual power is a brake power. And the ratio to brake power to indicated power, that is our mechanical efficiency, input upon output. Here, so sorry, output upon input. So that is our mechanical efficiency. So brake power upon indicated power, it's our mechanical efficiency. So here we are going to determine our our length and diameter depending on our indicated power. How you are going to find this indicated power? You are not going to find this indicated power. This indicated power is a requirement for designing IC engine. So indicated power is input, PM is mean effective pressure. What is the difference between maximum pressure and mean effective pressure? Mean effective pressure is average of our pressure in all the 4 cycles inside our cylinder, and maximum pressure is what is the maximum peak of pressure by working with all the 4 forces. L is the length of our cylinder, and capital L length of this is a stroke length. This is actually a small l. This small l, which is the stroke of our piston, and ultimately depending on the length of diameter, we have this empirical relation. This is length of stroke, which has established empirical relation, which is 1.25 times of T d, which is diameter here, which is d to 2d. Particularly in this subject, actually I have to tell you before, but I will tell you now. In this subject, we will come across few quantities which are empirical in relation, which doesn't have any kind of derived relation. So this kind of relation, which is directly put in our facilitation, depending on different experiment or real life scenario, which is L is equals to 1.2 times of diameter to 2 times of diameter. So which is also an empirical relation. Also, depending on the stroke of length, which is always 15% more. Our total cylinder length is always 15% more than stroke of length. So here, after finding this stroke of length, we can easily find total length of our cylinder, which is 1.15 times of length of our stroke. So ultimately, depending on our input criteria, which is indicated power, we can easily find our length of stroke and diameter, which is also determined by this equation. So ultimately, our indicated power will going to provide us length as well as diameter of our cylinder. So this is basically a subject, or you can say a concept of a cylinder, in which previously we have seen determine wall thickness of cylinder. Here we have determined the diameter and the length of our cylinder. After this, we are going to design cylinder stud and cylinder head. So that will in next video we are going to discuss about cylinder stud design and cylinder head design. So let's have a recap about this. And here in this video, we have determined the length and bore of the cylinder, which is depending on our input criteria, which is indicated power, which is equation of indicated power is PM and N upon 60, where PM is mean effective pressure, L is length of stroke, A which is cross section area of our cylinder, which is pi by 4 d square, and L is number of working stroke. In case of 2-stroke engine, number of working stroke is directly equals to speed of engine, and in case of 4-stroke engine, it is L by 4. Ultimately, depending on that, we can determine length of stroke, or we can put this length of stroke as an empirical relation of diameter. So this equation will become only equation will contain only to find out diameter only, and ultimately, depending on that, after determining the length of stroke, we can easily determine length of cylinder, which is 15% more than our length of stroke. So this is how you are going to determine bore and length of the cylinder. Clear? I hope you all have clear about this. Thank you so much. So we are stopping here for this video. After this, we are going to determine design cylinder head. Hello everyone, this is our last video for designing of our cylinder head. After this, we are going to move on to case study of our cylinder head. But in this last video lecture, we are going to learn about two aspects, last 3 and 4, which is design of flange and stud as well as cylinder head design. So basically, this is aspect of a cylinder head which connects with our cylinder with crankcase as well as overhaul. So in case of flange and strut, this flange is provided or it connects our cylinder head with the crankcase. Our cylinder head is placed over our crankcase which contain crankshaft. So our cylinder head is connected to our crankcase through flange and strut. Clear? So this flange and strut are ultimately made of a single material, or you can say single piece of cylinder block, and that cylinder block is bolted through our cylinder head with our crankcase. This flange is very much, it is a single component. Okay, you can understand this. This cylinder block and this flange also single made of single piece component, but this flange is way thicker than compared to any kind of cylinder wall. So flange is thicker than cylinder wall. If it is thickness of cylinder wall is T, then flange thickness will be 1.2 to 1.4 T, which is increased. Why we are going to increase this flange? Because this flange comes under immense amount of stress and ultimately it tends to break by this. So that's why we are using this flange, or we are making this flange as a way much thicker than our thickness of a wall. So after that we have to determine the diameter of strut. This strut comes under tensile stress, so the strut tends to shear this stress inside this also. The stress is also generated by, always in each and every component, stress is generated by force due to gas pressure, and ultimately this gas pressure will create tensile stress in our struts. These struts will try to elongate to vertical direction and ultimately it will come under shear stress. So for our equation for this strut is, this represent force due to gas pressure and this represent resisting force exerted by struts, which is pi by 4 d square into P is equal to Ns into pi by 4 into dc square into sigma T. So ultimately our strut designing is depending on shear stress generated in that due to gas pressure, where Ns is number of struts, which is represented by one empirical relation which is 0.01 d, which is diameter of cylinder plus 4 to 0.02 d plus 4. dc is strut diameter and sigma T is tensile stress induced in our strut material, where pitch diameter, this is ds diameter of bolt and d is stud or bolt, you can say anything. This is nominal diameter, this is overall diameter, this is mean diameter. Clear? Now this flange connects crankcase as well as cylinder, so it should have a leak proof joint. Here our strut will be placed in such a way that it should provide a leak-proof joint. Here, as well as we also provide gasket into that. But to have that leak-proof joint, we are providing strut in or make this pitch circle of strut like this. It should satisfy this condition. Means the length, or you can say pitch circle diameter, should be between 19 under root d to 28.5 under root d. What is d? D is a nominal diameter of our strut. So this nominal diameter of strut should be like this. This nominal diameter, if you want to consider this nominal diameter, it is considerable, or it can be determined by our strut diameter. It can easily determined by our strut diameter. So depending on that empirical relation, we can determine this pitch circle and which is consideration, or you can say a leak-proof joint can be produced by this consideration. It should be between 19 under root d to 28.5 under root d. The last step while designing the cylinder head or cylinder is to design a cylinder head. Cylinder head is basically a box section which is placed over our cylinder to provide a joint here which comes under direct stress and the relationship between the stress and thickness. So the thickness of the cylinder head will be different to the thickness of the wall. So this thickness is represented by dh, and which has empirical relationship with this stress, and which is d under root Cp upon sigma c, where sigma is allowable circumferential stress, which the value of this stress should be between 30 to 50 megapascal. Clear? Where d is internal diameter, P is maximum pressure. Here it is not mean effective pressure, it is maximum pressure. And C is constant, which is 0.1. So you are going to multiply this maximum pressure into 0.1 here, and ultimately depending on that pitch circle diameter of that cylinder head, you know, you have to join this cylinder head through some bolting or some riveted joint. So it is dP is equals to d plus 3d. So here you can see that this is also an empirical relation for that. D is internal diameter and small d is nominal diameter of stud. So this is all we have in designing of cylinder head. In this video lecture, we have learned about how we are going to join our cylinder head with crank case it is joined through. Let's have a quick recap about this. We are going to join through flange and stud, where flange joins our cylinder head with crankcase through studs, and ultimately we can design this stud easily, as well as we have designed cylinder head which is placed over our cylinder. Here cylinder piston assembly through the bolting. Here we have determined the maximum, or you can say cylinder head thickness depending on circumferential straight. Depending on that, we have find out pitch circle diameter. Also we have determined the condition for leak proof joint. For that, it should be between a 1900 D to 28.5 This condition can applicable at the both of the flange joint as well as cylinder head joint. Okay, cylinder head is above our cylinder, and the flange it is where we have to connect our cylinder head, or you can say cylinder block, with crank case. So this was design of our cylinder. After this, we are going to have a case study or more of an example which comes even in GTU also. Thank you so much. We are done with our cylinder design. If you have any query regarding this, you can ask me directly. Thank you so much. Have a good day. Bye.